All right, it's day 45. Let's get it. Yep. So here we have the question. There is a directed graph of n nodes with each node labeled from 0 to n minus 1. The graph is represented by 0 index 2D integer array graph, where graph of I is an integer array of nodes adjacent to node of I. So basically, we have an adjacency list. And meaning there is an edge. Yeah, there is an adjacency list. A node is a terminal node if there are no outgoing edges. A node is a safe node if every possible path starting from that node leads to a terminal node. Return an array containing of all safe nodes of the graph. The answer should be in ascending order. So, okay, basically, there shouldn't be any loops, right? Leads to a terminal node. A node is a safe node if every possible path starting from that node leads to a terminal node. Okay, every possible path. Return an array containing all the safe nodes of the graph. The answer should be sorted in ascending order. Okay, makes sense. I think we need some okay, let's see. Let's create some diagrams to now here we have perfect. Let's take this example, copy image, paste. So this is a graph, right? Let's take this also. Perfect. Now node 0 has outgoing edges to 1 and 2. Node 1 has outgoing edges to 2 and 3. Node 2 has an outgoing edge to 5, 3, 4. 3 has an outgoing edges to nothing. No, 3 has an outgoing edge to 0. 4 has an outgoing edge to 5. 5 and 6 are empty. So this is our graph. Now here, what do we need to do? We need to find out safe nodes. A safe node is a node where all of the possible paths go to a terminal node. Now if I start doing a BFS from 0, right? Let's say from 0 I go to 1, from 1 I go to 2, from 2 I can go to 5, right? But from 1 if I go to 3 and 3 I go to 0, 0 is already visited, so that is not a safe node. Then I start with 1. Yeah, basically in that way. Kind of a DFS approach, right? So if I want to do that for every node, basically doing a BFS, so it'll be n squared solution, right? There, because there are n number of nodes. And yeah, n could be large. I don't think that would fly. Go to a terminal node. So terminal node is a node which does not have any outgoing edges. So terminal node are 5 and 6. Let's flip this graph. Basically, invert the arrows like we do in topological sort, right? Let's try that. So from 0 there is an outgoing edge to 3, right? Yeah. For 1, how many? 1 goes to 0, right? No. What am I doing? No. Okay. Oh, we just flip that shit, right? Nah, this is bad. So 5 and 6, right? Yeah. I mean, we could do n square because I'm having a little bit of trouble finding out some other solution. Right. So 5 and 6 are definitely safe nodes, right? So it depends, like, should I find which of them, which are the adjacent neighbors to terminal nodes? Yeah, we could start from the bottom up, right? So 5 and 6 are definitely there. So 2 and 4, right? Our next neighbors. Yeah, that's what I was talking about, right? Yeah, flipping the edges. So from 6 we go nowhere. From 5 we go to 2 and 4. For 4 we were going to 5, but nobody is coming to 4, right? Nobody is coming to 4, so it's empty. Who is coming to 3? Only 1 is coming to 3. Who is coming to 2? Only 0, right? Who is coming to 1? Only 0, right? Who is coming to 0? Only 3, right? So terminal nodes are 5 and 6. For 6, nothing is there. Immediately go there. Then for 2 and 4, do a BFS on 2 and 4. Then for 4, yup. For 3 goes to 0, 0 goes to 1 or 2. Yeah, we won't catch that. I mean, yeah, but how does it simplify our solution, or does it? I don't think it does anything. Let's write BFS approach. So int n is graph.length, which is the n number of nodes, right? Now BFS on each node, right? For int I. Okay. Now we take a queue of integer. Okay. Q dot add I, or simply call another function, is safe node I and graph. If it is a safe node, then result dot add I. Now here list right. For all the neighbors, if that neighbor is visited, then return false, else visit that neighbor and add it to the queue, right? Queue dot add neighbor. And I think we need to do this in a layer wise fashion. So we do int size equals q dot size, while size minus minus is greater than 0. Then we enclose all of this shit in here. Right. At the end, return true. Current is already defined. Call this, let's call this root. This makes more sense. Okay. I don't think this will fly. If it flies, then great. Okay, first of all, it's a wrong answer. Now, why is that the case? Now, for this graph, what happened here? So 0, 1, 2, 3, 4. 0 goes nowhere. 1 goes to 0, 2, 3, 4. 2 goes to 3. 3 goes to 4. 4 goes nowhere. Now 1 is in my answer, 1 is a safe node. But it doesn't seem like it. 1 goes to 0, done. 1 goes to 2, 2 goes to 3, 3 goes to 4, done. 1 goes to 3, 3 goes to 4. Expected is this output. Oh. Okay. Okay, got it. So this visited logic is false, right? Or no? Yeah, DFS is the way here. Yeah, DFS is the way here. We don't need this, right? Let's write DFS. If graph root dot length is 0, then return true, right? Basically, if there are no neighbors to that root, then we say it's false, right? We also need to keep track of visited here. Right? So Boolean visited, if visited of root, then return false. Then for every neighbor in that root, first of all visit that neighbor, then do true. Answer equals is safe node. Not root, it should be neighbor in this case. Then visited of neighbor false, right? Yeah, if it is not safe node here, then we can immediately return false. Or let's say answer equals answer and this, right? Okay, what are we doing here? If it is this, then yeah. If visited of root, then return false. Else we go to each neighbor, we visit that neighbor, then we carry forward. Okay, we are not visiting that guy. Boolean visited equals new boolean n. Visited of I equals true. Then we pass this, right? No. For 2 and 4. Okay, let's take this. For 2, now 2 is visited, right? We go to 5. For 5, we have the length as 0, right? Yeah, so we return true. This is interesting. Why is 2 and 4 not here? Two goes to 5, right? Now for 2, visited of 2 is true, correct? Then is safe node. Ah, this shit is. Yeah. Now, I think here it should be there. If visited neighbor. Let's check now. Yeah, now TLE is coming. Now let's see the actual solution. Topological sort. Yeah, that's what I was thinking, but how? Let's see. Kiran Pal Singh's approach. The red colored nodes have 0 out degree, hence they are safe nodes. We can remove them from the graph. After removing 5 and 6 nodes which were connected with 5 and 6 have one less out degree now. Now 2 and 4 have 0 out degree, hence they're also safe nodes. Nodes which were connected with 2 and 4 have one less out degree now, but there is no node with 0 out degree, hence we stop the algorithm here. But why does this work? Why does this work? For DFS, we need to do some optimization. When we travel a path, we mark the node with 2, which represents having been visited. When we encounter a node which results in a cycle, we return false. All node in the path chain. We know leaf nodes are safe, and any nodes with only safe children are also safe. If we find a node already visited, we know it is not safe. Keep track of these two things, safe and cycle nodes, and return the safe ones. Oh, if I just add caching here, does it just say that? Now, if it is not safe, I can add a cache here. Safe of neighbor equals not safe of neighbor is true, right? Now, and simply if I can check here, if not safe root, and return false. Let's see if this caching works. Ah, shit. Okay. This caching works, but let's see if this does the trick. Yeah, still we need more optimization. Okay. What else? I mean, what is this guy doing? Oh, we have to cache safe nodes as well. Okay. Let's cache them as well. Safe of I equals true. If safe root, then return true. Okay, we are making progress. Still, what? Use test case. Okay. If safe neighbor. If neighbor is safe, then continue. If neighbor is not safe, then return false, right? Yeah, still. What is this guy doing? So DFS, if safe nodes dot find I, then return true. If cycle nodes dot find I, if visited nodes dot find I this, cycle nodes dot insert I, return false. Then we insert that. Then we go to each neighbor. Cycle nodes dot insert I, return false. Safe nodes return true. Okay. Visited nodes. Are you preparing for an interview? Yes. Yep. Uh, yeah, Leetcode is for interviews. Yep. Let's see, this might get accepted. Okay, it works, but the time complexity is pretty shit. Ah. Okay. For which? For any company, brother. Any company. Now let's see why topological sort works more faster. Okay, let's see this. Okay, I've already done this question with the similar time complexity here, and this was C++. What was my code? In degree, out degree. What's the best solution? Let's see this solution. What is this? If visited, I am not a student. I am already working in a company. So, yep. I'm just doing Leetcode, man. Just getting in the habit of doing questions. So, yeah, that's the deal. Okay. I can't tell you that. That will be confidential. I mean, I don't want to disclose that on YouTube, but yeah. And that shouldn't matter. I mean, yeah, I'm just prepping, man. Just doing Leetcode. Safe and visited. Okay, this seems okay. Then for int this to this, if it is not visited I, okay, visited of I is true. Okay. Yeah, I mean, I can do here also. If safe I or okay, it gets 2 milliseconds faster. Okay, now this is 36%. Okay, what did I do here? This one, right? Corner. Okay. Yeah, it works, man. The time complexity would be, what is the time complexity here? Let's look in the editorial. M plus n. M plus n. DFS m plus n. Okay. Yeah, so this is a DFS. If it is in stack, then true. If it is visited, then false. Yeah, it's whatever, man. Okay. Okay, so this was the daily challenge. Let's do one more from Leetcode. We were on 2 pointers. I think this was done. Yeah. Let's do threesome. Given an integer array nums, return all the triplets ijk such that they are not equal to each other and they target to sum at 0. Okay. Must not contain duplicate triplets. Okay. First of all, it's not sorted. Must not contain duplicate triplets. Now, if the values repeat, should I include that or not? It should, right? I have done this question before. Is it just fix one index and then do a two sum on the other remaining array? Is that what this question means? It might be the solution. Let's get it. So, first of all, we sort this. How do I sort? Numbers equals arrays dot what? Okay. I think it is nums. Int array to list. Dot boxed dot collect. Now here for int I equals 0, I is less than n minus 3, right? Yeah. Now I have an I just need to do a 2 sum on the remaining array. int L, int R, then we have we pass in nums, right? And then what do we do? Numbers. If sum is less than target, then L plus plus, else R minus minus. I actually need to return L and R here, so list integer. I will return list dot of L and R, else return an empty list. So we can call here to sum. If answer dot size is greater than 0, then press add list dot of I, and target is actually 0 minus numbers dot get I, list dot of I answer dot get 0, answer dot get 1. Okay, what happened here? Arrays dot stream, it's stream. Arrays dot sort, no suitable method found for sort list of integer. What happened here? Sort a list of integer in Java. Collections dot sort. What the fuck? Oh shit. Oh, I have to get the numbers. Okay. So numbers dot get I. Hi Bisal. Hi. Numbers dot get. Numbers dot get. Yup. Let's see if this works. Okay, there are duplicates, so we cannot have duplicates. Okay, but this isn't exactly duplicate. Fuck. Okay. We can't have duplicates in of any case. I mean, we can cache them, right? We can put them in a cache. This is my answer, right? So list of integer res equals this collections dot sort res, right? In here we will say or set cache a list of integer in Java. Okay. Now in here, this is okay. Rest node stream dot map Oh shit. Okay. cars.add cars.contains. If cache.contains, let's see, collections.sort res. What? Unsupported exception. You know what? Let's see what I did last time. Yeah, I did the same thing, man. I can sort before boxing it, then in result okay, if I is 0, if I is equals 0, or nums of I is not equals nums of I minus 1. Okay, this is way cleaner. This is way cleaner. Okay, great. So some mistakes here. First of all, we can sort nums using this, and this is my result. We don't need a cache. Then from here, if we don't need duplicates, right? So if I is 0 or nums of I is not equals nums of I minus 1, then we find duplets, and these duplets can be multiple of them. Right? This will be I plus 1 nums dot length minus 1 nums, and 0 minus nums of I. Then for list of integer in duplets, result dot add raise dot as list what was that? Or I can simply do list dot of nums I nums of d dot get 0, right? Nums of d dot get 1, right? Now for to sum, Instead of returning just the first duplet, we need to keep them in a bigger collection because there can be multiple of them. I don't think this is required. Now, while L is less than R, if sum is target, now while nums of L now this is interesting. What did I do here? If sum is target, yeah, here we need to do a bunch of shit. First of all, duplets dot add L and R list dot of L R while L is less than R and nums of L is equals nums of L plus 1. We move L. Similar shit for R. Oh, fuck. Okay, why is this not added in here? If R is nums dot length minus 1, that is correct. While L is less than R, if sum is equals target, then we add that to the result. While if it is less. Okay. If sum is greater, okay, this is an interesting catch. Okay, still. Okay, this fucking hell, man. L plus plus and R minus minus, which is correct. Because we want to continue. Else, okay. Got it, my friend. Yep. This should work definitely. Okay. So this was threesome. Okay, so it's just a extension of two sum, right? We keep one integer fixed and then we do a two sum on the rest of the array, and we should be careful about all of the limits and stuff like that, right? So yeah, these were the two questions for today. It's been an hour. What the fuck? Today was a stinky day for Leetcode, but yeah, we continue anyways. So now here, if we go okay, January looking pretty fine, not a single weekday missed. So I'll be back next week. Until then, GG's.